So I was asked if I started recording, and I didn't. That yellow post-it sitting 5 inches from my nose isn't working.
Wow.
I apologize. Well, you guys are here, so you got to hear it, but we'll be a little bit truncated for the rest of the folks that they're going to pick it up later on. So getting back to this concept of short-circuiting these expressions, the goal of the AND operator is that everything in the expression, if we keep adding AND, double ANDs in here, so AND C and AND D, everything has to be true for it to evaluate to true. So if at any point, as the interpreter is going through here, expression by expression, as soon as it hits a false expression, again, it short circuits and says, well, that's it, that's false. There can't be any other result now because there is a value and there is an expression here that is false, so it can't evaluate to anything else at this point because we're using the AND operator. So as soon as it hits that false value, it says, okay, the whole expression is false. So even if I had and C was true, and D was true, those would never be evaluated because as soon as that interpreter hit that false value, it says, oh, that makes everything false. Down here, it's just the reverse with the OR. As soon as we hit a true value, then it doesn't bother evaluating the rest of the expression because it says, as soon as we get a true, that makes the whole expression true. So that's again, that concept is referred to as like short circuiting. So then we have a list down here, those two operators, and then just a if statement, which is one of the most common types of selection structures that we can use, decision structures. And so the way that an if statement works is that it will have an expression, it will evaluate the expression, and based on the results of that evaluation, if the expression evaluates to true, it'll run the code in, and you'll see that when we set up an if statement, you'll essentially have the equivalent of a true section and a false section. So if the expression evaluates true, then it's going to run the true section of code. If the expression evaluates to false, then it runs the C in this example, or the false section of code. And thinking back to the flowcharts, remember we talked about using the diamond there to represent decision making within our program. So at point A here, what's happening is we're applying this expression here to see if A is true. And if it is true, then we're going to run the code that's here in B. If it's false, then we're going to run the code here in C. And then we have the terminal value, the end of the program there listed at the bottom of that black circle. So let's start playing around with this a little bit. We'll go ahead and open up our Visual Studio program. We'll put together this little bit of code here. In this particular case, you can see we're setting up two integer variable types, number 1, number 2, assigning values to them, and then we just simply want to do a comparison. So essentially this is, this program up here, take in two values, evaluate those two values to see if one is greater than the other, and then depending on the results of that expression, we'll generate this output. So in this particular example, it's only going to get that output when number 2 is greater than number 1, which it is because number 2 is 20 and number 1 is 10. So let's just put this into a program real quick, see it run. So I'll copy that block of code, open up my Visual Studio. Get my window over here. It's on the wrong side. There we go. Okay, so with our Visual Studio Start screen here, we want to click on Create a New Project. Of course, it's going to be a console app, .NET Core, C#. And let's call this one If Statements. Or actually, we'll put a lot of them in here. Let's make the solution read decision structures. And then the first project will be an if statement. So I got a project name, if statement, and I've got a solution name, decision structures. So I'll click create. And there's my Visual Studio, and there's my program. Let's go ahead and just replace the code with what we copied. So there's our whole program. So we're using the system again because we're using the console down here. Then inside of the main, we've initialized an integer, number 1, with a value of 10, integer called number 2, value of 20. Here we're doing the comparison, and then here we're generating the output. So I'll save that and run it with a control F5. And if everything's working correctly, we should get that output there. Number 2 is greater than number 1. Amazing, isn't it? Not overly impressed? All right, so
I mean, it's pretty.
Go ahead.
I mean, it's pretty cool.
Yeah, when you think about it, that's an actual bunch of zeros and ones flowing through your CPU and actually telling it what to do to make that evaluation and then give us the results. But it is pretty basic stuff, I'll grant you that. So this is just emphasizing the point then that we're doing our conditional expression here in the parentheses of the if statement. So the format is if, and then it doesn't really matter if you have a space there or not, but set of parentheses, and in the parentheses is where you put in the expression that you want to be evaluated. In this case here, we're just evaluating the one expression, looking to see if the value in number 2 is greater than the value of number 1. Now, if that weren't the case, I mean, if we go back and run this again, if we make, say, 1 the value of 30, well, now if number 1's greater than, so when I run this, I just won't get any output. Right, so now it skips that console write line statement altogether because this evaluated defaults, it skips everything in the curly braces that makes up the if block. So that's the basic components of an if statement, is the keyword if, followed by a set of parentheses. Inside of the parentheses will be 1 or more expressions. And depending on whether that entire expression evaluates to true or false, if it's true, it'll run what's inside of the code block for the if. If it's false, it'll just skip beyond that. In this case here, the program just ends at that point. Any questions about that so far?
Nope.
Nuh-uh.
So here is the flow chart that just represents what we just did in code there. So another way of visualizing it, right? Our starting point, assigning some variable the value of 10, some variable the value of 20, comparing the two values, and then generating the output that one is greater than the other, depending on the results that we have. If it's no, we jump by that output statement. If it's yes, we print the output statement. So now we get into a nested if statement, which means you're putting an if inside of an if. So you can see in this particular program, this example here, now we've got our integer number 1 equal to 10. And then we do a check then to see if number 1 is greater than 5 or not. If so, we'll go ahead and write out this expression. Number 1 is greater than number 5. And then after that line of code is written, then the next thing is to check to see if it's also less than 20, which it is in this case. So then it'll go ahead and write out that value. So 2 checks then in this particular case being made. 1, are we greater than 5, which 10 is, and are we less than 20? So let's put this into our own little project, and then we can play around with it a little bit. Back into our Visual Studio now, just adding a new project. And this one's going to be, again, C#, .NET Core, console app. We'll call this one nested if. And let's right away right-click here in the Solution Explorer, make that our startup project, and then we'll go ahead and replace the code. That's interesting. I guess we didn't get all that when I did a Control A. Interesting. All right. So just copied everything there from what we're seeing in the lesson. So again, establishing and initializing our variable called number1 here as an int and a value of 10. Then we check it to see if it's greater than 5. If so, we'll do this output. And then check it again to see if it's less than 20. If so, generate that output. So go ahead and run this, Control F5. And as you might assume, we should get both outputs there because number1 is greater than 5 and it's less than 20. Now for starters, I was thinking that another way to generate the output here is if we just simply put in our string interpolation operator. We could actually get the actual value from number1 instead of just saying number1, which really doesn't visually tell us what the value is in there. See, now we can actually see what the value is, and that'll say this number is greater than that number. So whatever the actual value stored there in the variable number. Okay, so we'll go ahead and run that. Still the same values there. But it just makes it a little more sense on the output. So we got 10 is greater than 5 and 10 is less than 20. So now then, let's make a value that is not greater than 5, but is still less than 20. So 4 would probably work there. So instead of 10, now we're 4. Let's go ahead and run that. And that's right. This is an interesting way to do this because what you see now is we get no output. The reason being, this is a nested if. So as soon as this expression here evaluates to false, right? Right now it is false because integer, or number1, I should say, is less than that number there, right? So this expression now is going to evaluate to false, and all the rest of the code is inside of that if block. So as soon as this right here evaluated to false, the interpreter jumped down to here. It skipped everything else. So another way to have done this instead of the nested if we wanted to actually see both of those values, would be to put them sequentially after each other instead of one inside the other. So now it'll run this block of code based on this evaluation. It'll determine whether or not we write this line of code. And then it'll, because it's outside of that initial if, now we'll also evaluate this expression and determine whether we should write this line of code. So let's save that and run it. And now you can see we do get the expression that 4 is less than 20. So we skipped this first block because, again, this evaluated to false. But now because this if statement was outside of the other if statement, it's no longer nested, then it did, the interpreter did evaluate that expression. It evaluated the true, so it went ahead and printed out that line. So that's a good example for you to stick in the old gray matter there so that you understand, you know, the impact. And when you go to write your own code, hopefully better understanding whether or not you should use a nested if or not. Usually, and we'll see this when we get to our decision structure later on, the nested ifs work really good when you're evaluating the value and checking it for several different conditions. Like in the decision structure, you know, it's going to be, you know, if you bought this amount of quantity, here's your discount. If you bought this amount of quantity, here's your discount. And so we could do that in a nested if. Okay, we jump back to the lecture now. So another way to handle what we're just looking at, now here I wrote it out as 2 separate if statements. Another way to do that is to do it with an else if. So let me go back to where I was here. And actually, probably I should write a new project here, but just let me remind you what I just had here. So this is two sequential if statements, not nested like it was originally. In this case, it will, when I say it, I mean the interpreter will evaluate this expression for true or false. If it's true, it'll go ahead and run this line. And regardless of what happens here, it will then, the interpreter will then move on and it will check this expression here, and whether it's true or false, you know, it generates the output here. If I would prefer, you know, if my need in my program is as I'm checking values, if I want to make it so that the expression that evaluates to false, or well, I should say, I guess the first expression. If I want the first expression to be linked to additional expressions, then what we want to use in here is else if. Because what happens in an else if is the interpreter checks the first if. If that's false, then it goes and it checks for the second if. But only if this returns false.
So it's basically the same thing.
No, a little different, because look at this. This is, the interpreter will check this expression, and regardless of whether that's true or false, it'll check that expression. But when we add the else before it, that's basically linking it now to the previous if. So I could have a whole list of else ifs down below here. So now, because it's linked to that first if this first if evaluates to true, then the interpreter will run this line of code and then skip all the way down here to the bottom. It will ignore that else if.
I mean, in the false part.
So if the if evaluates the, well, that's not the false part. Don't think of it that way. No, these are two separate.
Oh no, I'm talking about if the top one's false, then the else
right.
if will be
then it'll check the next else if. And let me copy that and kind of put a few of them here. So let's just say we had a bunch of different checks here, and I'm not thinking this through, so I don't know if I have my values that make sense or not. But just a bunch of else ifs. So the way that this works is I'm going to check, the interpreter checks this one. If that's true, run it, and then skip to the end. But if this first if the expression evaluates to false, then it checks this one. If that's true, it'll run that block of code and then jump to the bottom. But if that one's false, then it moves on to the next one and checks that expression. If that one's true, it'll run this, drop to the bottom. If that were true, if that were false, then it would skip that one, that block here, and then check the next else if. So it keeps checking all the else ifs as long as each previous one was false. As soon as we hit a true within that group there, it's going to run whatever the statement is that's inside of the block for that particular clause, if clause, and then jump to the bottom. It'll skip all the rest of them. And I think I might have, yeah, this one right here shows you exactly that. So let me go ahead and copy this. Let me start a new project here. Just again, C#, .NET Core. And we'll call this else if. And I'll go ahead and put that in there. So now we have a variable n. It's assigned the value of 10. We're checking to see if it's less than 10 initially, which it is not. So it should skip that line of code. Then it's going to check to see if it's less than 20, which it is. And so at that point, then it should just jump down to the end. It'll write out that line of code and just jump to the end. Because this expression is also true, right? But it's the first expression that it hits that's true. It runs the block of code inside of there and then skips everything else. So let's go ahead and save that. Let's go ahead and run that. And see, there we get the output of 4 is less than 20 because that's the first expression that it hits right here that evaluated to true. See, this was not true, it was false, so then it made the next evaluation. So we could, let's make this now 20. So now that should give us this true. These first two should be false, and this should be true. Let's go ahead and run that. It's interesting, that did run it, didn't it? Okay, there we go, run it. So now we only get the output n is less than 30 because this evaluated false, skipped it. That was a false, skipped it. This was true, run it, jump to the bottom. And then let's just increment it one more time here. Let's make it 30. And so you'll see the very last statement here is not an else if, it's an else. So think of that as a catch-all, meaning if everything else up here evaluates to false, then go ahead and output that line of code right there. So let's save that, go ahead and run it. And there you can see n is greater than or equal to 30 is the output that we get, the very last line there. So the point of the else if is, it's like an if in the sense that when it evaluates to false, it'll just skip all the internal block. But it's linking the ifs together so that if one condition is false, then we will have another condition to check. And if that's false, then we got another one to check, on and on as many times as you have an else if. And then if you want at the end to have a catch-all, then you just add else in there. And so if everything else above it is false, then go ahead and run that line of code. Make sense?
Yep.
Okay, so the else statement is the next thing here in the lecture. So you can see as we go through this, this is how we'd write it in the flowchart. So we're checking to see initially if n is less than 10, and if it is, we got the output. And there you can see after the output's generated all the way down to the end of the program. Then the second if, then the if else. Again, if it's true, goes to that output, skips everything else. But if we're false, right, you can see we just keep moving down until we get to that final else statement where the output in this case was n was greater, equal to, or greater than 30. So just a flow chart representing the code that we wrote there. Okay, so we covered if, nested ifs, else ifs, and just else's. So that pretty much covers the whole combination that you can package together with your if statements. So now we move on to another type of structure called a switch statement. Switch statement is also another way of creating a multi-way branching scenario. And switch statements in many cases, as it says here, can actually simplify having a bunch of else if statements. So the way that the switch statement works is that it'll have a key word that's going to be passed into the switch statement. And then you'll see that we'll have a bunch of expressions then that we evaluate. So let's find right here's the beginning of the switch block. So it's keyword switch inside of parentheses. In this case now, it's not an expression that's being evaluated as true or false. It's just simply a variable that has a value stored in it, and we want to compare the value that's stored in that OPR variable with what we call the cases that are set up down here. And what this particular example is doing is just setting up a simple little calculator. So the idea is that we're going to have these two values already set up, 10 for OP1 and then 20 for OP2. Those will be the actual values. And then the operator is stored in OPR, and the default is, this is all hard-coded, going to be a plus symbol. So what'll happen is the switch block and the value that's stored there in the parentheses gets evaluated to identify whether or not it matches one of the cases that we see down below. So we have the keyword case, then you have the value followed by a colon, And you can think of that kind of like the expression, kind of like in the if. And then here we have the actual operations that we want to run, the statements that we want to run, these two lines of code here. If OPR is a plus symbol, do this, run these two lines. And the main line is this first one. That's where we're actually taking the result variable here and assigning to it the addition of our two variable values to each other. Now, the way that these switches work is if you don't put a break command for each case, it'll do what's called a fall through. In other words, it would run this right here, but if I didn't have break here, even though that character, the OPR, is not a minus symbol, it would still continue to run down here. So for each case that you write out, you always want to make sure that you end it with a break. So you got a case for the plus symbol, we've got a case for the minus symbol, we got a case for the multiplication symbol, case for the division symbol, and so you can see that the operations that we're doing are just really using those symbols with our operands, our values. So if any one of those is met, it'll perform the particular operation that's the correct operation. Now, if none of those are met, we should always have a default down here that will catch it. And so here, if it's not one of these symbols, then we would assume that the user typed in, of course they didn't type it in, but the value that was provided was an unknown operator. So whatever was typed in up here wasn't a plus, a minus, an asterisk, or a forward slash. So we can catch that right here because it didn't match any of these. So the very last resort then is go ahead and run this line of code here, and then notice a break as well for the default. After we run the switch, then we just simply output the value of what the result variable is then at that time. So a simple little calculator. Let's go ahead and set that one up in our Visual Studio. I'll copy that back to Visual Studio. Let's go ahead and create another project here. And we'll just call this one a switch. Replace my code. Okay, so we got our using, we got our namespace, our program inside the main. Again, we have a result that's going to hold the results of our operations down here. And then I've got two operands, each assigned a value. So 10 is what OP1 is the value of, and OP2 is the value of 20. And then we identify what our operator is going to be and assign that to our OPR variable. And that's what gets passed into this switch statement here. That gets evaluated for whatever its character is or whatever's stored in that variable, and then it just goes through here line by line or case by case, evaluating to see if they match. Once they match, it'll run whatever statement or statements are inside of the case, and then it'll hit the break, which means it'll skip outside of the switch after that point. So at any point in here where we match it, we're just simply performing the mathematical operation on the right, assigning the results of that mathematical operation to result, and then down here just outputting then the value of result. So let's use the plus symbol. Let's go ahead and save that. And I didn't set it to the default startup. There we go. All right, so let's run that. So there you can see that if you add 10 to 20, the result is going to be 30. Let's change it to a multiplication operator instead, and then run it. So now we've got 10 times 20, so the result, of course, 200. And of course, we could change that operator all we want here. If you want to get really fancy, you could actually take input from the user for your values, and you could take input from the user for the operand as well. This is just, for simple demonstrations, it's good to put the hard-coded values in there. When you're writing a program, if you want it to really be functional, usually you want to take values in from the user, because otherwise it's always running just fixed values, right? Any questions about that? That's probably the more difficult structure that we've seen as far as our decision structures. But if you just look at the way that it's written out here, you can see that it's just the keyword switch in parentheses. So kind of like the if and then parentheses and then the expression you want to evaluate. And so whatever this evaluates to, being compared to each of our individual cases, and then running the block of code wherever the case is matched. And again, the very important thing here, make sure we get a break in each one of those cases. Now there's actually times, in fact, I think I have an example of it here to show you in a second, where we might want to have a fall through. Let me double check. I think I have that in here. Yeah, so this is using the switch statement in a fall through method, they call this. This is pretty interesting because it's the same exact format that we just saw there. Here's the switch keyword. Here is the value that is being evaluated. And so DT is just going out to your computer clock and grabbing the current date and time and then returning the actual name of the day. So Tuesday, for instance, would be our day value right now. So that's what's being passed into the switch block here. But instead of writing out this line of code that today is a weekday for each case, that would be, redundant. So instead, what's happened here, you can see that all of the weekday cases were grouped together so that if any one of these get matched, it goes ahead and it runs this line here that it's a weekday. If none of these are matched, then the assumption would be it must be a weekend. So that's the default output, is if none of these match, then go ahead and write out the code that says now it's a weekend. So I'll go ahead and put this in our Visual Studio and run it. Do one more project here. Just call this switch block. Make it the default program or the startup and paste our code. There we go. So this should resolve the Tuesday, since I'm not going to change anything here. Or should resolve the weekday. That's the only two outputs we get, weekday or weekend. So again, just taking whatever the current day is from the actual user's computer and its clock, evaluating that to see if it compares to any of these weekday values, Monday, Tuesday, Wednesday, Thursday, Friday. If it does match any one of those, it just outputs then that it's a weekday. If it doesn't match any of those, it's going to identify that it's a weekend. So how are we doing? Is that all making sense, everybody?
Yeah.
That's a little bit trickier version of the switch statement. Any questions about it?
Sorry,
No?
I yawned.
What's that?
I said, sorry, I yawned.
Oh, you yawned. Understandable. All right, so what we're going to do now is we're going to take a 10-minute break, and when we come back, I'm going to go ahead and take you through that decision table that I presented to you in an early lesson. I told you at a later date we were going to go ahead and break that down into an actual computer problem, a computer program, and so that's what we'll be working on next. So go ahead and add 10 minutes to your timepiece. Come on back. So in this section then of the lecture, what we're looking at is, again, how to be on your own as a programmer and start locating information as you need to write new programs. So we start out with the console object, and it basically shows you to go into the Microsoft Developers Network and gives you a link there to get to this .NET Framework class library, which actually has been updated since this graphic was captured. But in that library, they have everything organized into namespaces, and in the system namespace, as we mentioned to you from the very beginning of the class, that's where we find the console object. And so this is just basically taking you through locating the console object. And then once you find the console object, start looking at the methods that go with that object. So let's see, let's click in here. So here's the new format for it. It's a little bit different, but similar. So just knowing that system is where we want to be, we're going to click on the link on the left here that reads system. And that'll give us then all the makeup, the components that make up that particular namespace. Over to the left, and this is where it has changed. It used to have all of the methods and properties listed here initially. Let me see if I have to drill down further from here. They just changed how we get to that. Let's see what's under here. Oh, there we go. So it's under application identity now. So once you get to the actual namespace that you're looking for, in this case system, then you want to come over here on the left, expand open where it reads application identity, and there's the properties and the methods. So we're more focused on the methods at this point. And that's a Tuesday morning brain fart there, because yeah, see, they changed all of this now. This is the system. I should point this out while we're here. So every time we did a console project, I had you select the .NET Core library. So the change that they made to the .NET Core is that they added Microsoft at the beginning of a lot of their libraries. And so that's so that they won't conflict with other libraries that are out there, from Apple, from Google, from Adobe, you know, whoever. So we can now, you know, what they've been working towards is this universal environment, meaning that you can write code once and then have your program run on all platforms out there. So that will help support that. But as far as the particulars on system, yeah, all they're showing us is library, library, library. I'm looking for, and I don't see it, is just the components. Maybe it's under here. No. Yeah, this is, I just don't care for this. Like the other one was just so much easier to drill down and get to. You know, the makeup, what's in the system library as far as all the objects. Let's go back here. Here's the SDK overview, so hopefully it'll be in here. Let's see. I still don't see libraries. Well, son of a gun. I'm going to have to go back and do a whole new tutorial just on how to find Microsoft libraries now, apparently. So let's do it a different way. Let's just search for C# system.console. Okay, so that takes us to the console class. So yeah, I'm going to have to redo all of that lecture now because the drill down that we used to have is just not available to us anymore. So we're focused mainly on the console object, which is in that system library. In fact, if I scroll up here, I'd be willing to bet. There you go. See, system at the root. Why they didn't give us that in the other view that we're looking at, I can't say. But anyway, so once we get to the actual object then, or the class, the console class, then we want to look at its properties and its methods, and we're mainly focused on the methods here. So we taught you how to do the console write. So I can just click there and I can see all the different options as far as what information I can pass into that console write. So inside of the parentheses where we stick in our values that we want to have output to the screen, you can see there's actually a lot of different options, different data types that can be passed into it. You know, we've been basically using strings up to this point, but you actually can put other values in there as well, other data types. So write is what we've been using for output, but then we also want to take a look now at how we take input. And so you can see we have both a read, actually we have three of them here. We've got a read key, where is it? There's read key, and then read line. So read and read line are just like write and write line. So write and read don't generate a line feed. Write line and read line, they do generate a line feed. Read key would be to actually accept the input from the keyboard as a char value, so we know what key is being pressed on the keyboard. Whereas normally, remember, the input is string. So a string is actually just an array of chars, but it is a completely different data type as far as the interpreter is concerned. And I keep saying interpreter because I realized I was doing JavaScript all week long, and we're in an environment now where we're actually using the compiler. Same difference, just taking our code, putting it in the format that can be run by the device we're running it on. Okay, so unfortunately, this lesson here definitely needs some reworking because they don't have the ability to drill down from that link that I give you right here. So I'm going to have to fix that so that you'll have access directly to these different console methods, and you can do a little bit of research on them. But, you know, that is, again, the objective really is to expose you to the fact that, you know, once you get out of the classroom, then as a professional programmer, you need to start, you know, building up your skills on your own and getting more in depth and more understanding and just become a better programmer. That's what you're going to need to do a lot of research and searching out for all these different objects and what their methods are. And eventually you get to a point where you've had enough exposure where you can, you know, pretty much write just about anything using the basic objects that are available to you. Now, when you get to hardcore stuff, like when you're drilling down and having to deal with hardware directly and things of that nature, that can be a lot more complicated. In addition to introducing you to the read and the read line method here for the console object, and the next thing that we talk about is converting your input. So again, remember I said the input on the keyboard by default is going to be string. And so anytime that we want to use numeric values in our program based on input from the user, we're going to need to convert those input values from the user into actual numeric values. So in the C# language, they have this structure. It's like a class. The structure is very similar to a class. It's just blocks of code that in this particular case represent the actual structure of what an integer looks like internally. All we care about is that can store a numeric value for us. So if you move down a little bit further here, you'll see there's a couple of ways to go about this. Down here in the note, I've identified that there's a parse method that you can use. In fact, it's showing you that one right here in the graphic that I did a screen capture on. So if you go in and you look at the int32 structure, so going back here, if we did C# int32 struct, there's the int32. Again, that's part of the system library. And so again, you can see that it has fields and it has methods, compare to, equal. Here's the parse method. And toString would be if we already had a value in integer format. The other one that's interesting is try parse. So parse is used on strings. So if I do like an parse int32 on a string value, it'll look in the contents of that string for the first numeric value, and whatever that numeric value is, if it exists, that'll be converted then into actually a number. Whereas the try parse actually is like a Boolean expression. It will return a true false value as to whether or not the parsing is possible. So it might be that you get a string input from the user that doesn't have any numbers in there, and then you try to process that numerically, you know, that's going to be problematic. Your program most likely would crash. So this helps preventing that from happening. We can actually test it out first to see that there's an actual numeric value in there before we continue writing the rest of the code, or processing it. We know it's in the right format if we, or that exists, I should say, a number exists in that string if we use that first. And then another option that's available to us is the convert class. So in the convert class, you can see that it has a lot of to methods. So convert dot and then 264 or to Boolean or to byte or to char, date time, decimal, double, int 16, int 32-bit, int 64-bit, to byte, to string, to unsigned ints, on and on. So either of those methods, parse, and we wouldn't really use try parse quite yet because we're doing it more simply. We want to make one statement that's just going to do the conversion for us. So you could use parse, or you could use convert anytime that you're taking input from the user and you need to convert it to a numeric value. So that's what that section's all about. So as far as writing out the code then for our program, what we need to do is to use that read method or read line, depending whether what we want a line feed, which is going to take the input from the user, then using either the convert or the parse, we'll convert that value that they're typing into a numeric value, and then we can go ahead and perform mathematical calculations like because what we're going to take from the user, getting back to our decision table here, what the input's going to be is going to be the amount that the user's purchasing. So everything else internally would be a calculation based on the user's input, right? So whatever the user types in is the quantity that they're purchasing, that's what we're converting to the numeric value, and then using that numeric value, what the quantity is, then we can go ahead and start making evaluations, right? Setting up expressions that evaluate those different rules that we have here. Is it less than 10? Is it less than 50? Is it less than 100? And if so, here's the results as far as the discount is concerned. Okay, so basically here at this point, just giving you the line of code that we would use to take the input from the user, and using the parse method in this example, convert that into an integer 32, which would be stored in an int data type named quantity. And you can name it whatever you want, but that certainly makes sense, based on our table here. That's what we're looking at, right, is quantity. So okay, so then you can see that we're putting in here the output of what the user typed in as their quantity. And if you look a little further down in the sample that I have for you right here, you can see that we have a prompt first that asks them to enter the quantity. Then we actually take the value from the user using the read line, convert it to a 32-bit integer, assign it to quantity, and then we follow that up with here's the amount that you typed in. So that just gives us the quantity. We haven't really done any calculations based on our decision table yet. So that's kind of the first step, or the first grouping of blocks that we're going to have in there, just taking input. And that's something you guys, I don't think I've seen any problems with this, but every once in a while on like the online class, they don't put the prompts in there. So you just get a flashing cursor, and the question always is, well, what am I supposed to type in? So it's always important, especially in console apps, that we're prompting the user, identifying to them what type of input we're expecting from them. Okay, so now that we have the input, the next thing then is that we would want to compare that value that we got from the input to the breakdown here in the conditions. So this is the conditions that we're going to use to set up our expressions to determine what discount the user is going to receive. So I've broken down the decision table into individual statements here. And this would be kind of the pseudo code if you're thinking back to the days when we talked about how we start forming a program. So first, it's if the customer purchases less than 10 units of product, they're going to get a 5% discount. If they purchase less than 50 units of the product, they're going to get a 10% discount. If they purchase less than 100 units of the product, they get a 15% discount. Otherwise, any purchase where the number of units is higher than previously stated, the discount is 20%. So you can see in, just 4 simple lines of statements there, we've pretty well kind of created the expressions that we'll be evaluating here in our if blocks. So just kind of evolving the statements that we have here now into this structure. So this here would actually be just more like writing down the algorithm initially. This one here is actually getting even closer to code format. So this would really be kind of the pseudo code. So if quantity, which is our variable, is less than, and then the value there, the discount would equal that. So that's pretty much all completely written out for us. It's not quite in formal code, but pretty darn close. So just taking those 4 statements that we see there, here now you can see we actually converted into the code. So we're doing an expression, and notice that we use the else if technique here. So we're testing this first value to see, is it less than 10? If so, give them a discount of 5. Else if, in other words, if it's 10 or greater, then this line of code is going to run, and we're going to check to see if it's less than 50. If so, assign the discount value of 10. If it's 50 or greater, then both of these would return false. So now we check this expression to see if the quantity is less than 100. If so, give them a discount of 15. If all of those fail, then we're going to give them a discount of 20. How are we doing? Is that, you following along? Is that making sense to you?
For the most part.
What are the parts that aren't making sense?
No, I'm just following along. It's just long.
Well, it's, I'm trying to take you through the thought process here. So I'm trying to identify step by step how you would look at that graphic, that decision table, and start writing things out, like I say, kind of in initially more just an algorithm format where we're kind of getting the steps in order here, setting up the conditions, but not as close as when we did down here. We just went through these statements again and made them a little bit closer to code, and then we took this statement and actually started writing it in code. So it's just kind of an evolutionary process. If you can look at this and jump right to here and start writing that, that's fine, that's great. But for a lot of folks, it's better for them to think it out in using these steps first. And then once they have that point, usually then it makes it a lot easier to write out the actual code here. Now, the next block is introducing you to creating a custom method. The idea here is that we want to actually perform the calculation process outside of the main program. And this is pretty typical of how you'll eventually learn to be writing programs. In fact, we're coming up in, I think, assignment 4, I believe it is, where you have to write a custom method. So the idea of a custom method is just simply we want to have a block of code that it's like a variable almost, if you think about it. What we're going to do is we're going to assign a name to a block of code, several lines of code. And then every time that we reference that name, it will run those lines of code. So the difference between it and a variable is a variable just has a value stored in it. In a function, it's going to actually perform some operations, and it may or may not return a value back to the caller. So that's how our methods, functions, by the way, are the same. And you'll hear me confuse the word, and I apologize for that because I keep going back and forth between JavaScript, which uses functions, and C#, which uses methods. It's hard to keep it all straight sometimes. I talk faster than my brain thinks. That's my real problem. But anyway, getting back here to creating this custom method. I'm showing it to you as a single line of code here, but it's best really to look at it in the sample down here. So notice that we're still inside of the program that we're writing. So here's the open curly brace for the program, and then down here's the closing curly brace for the program. So all of our code is inside of our program. What we're doing different now is that we're not writing out these statements here inside of the main method. So remember, every C# program always fires off of whatever is in the main method first. So the idea is that we may want to run this calculation multiple times. If so, I wouldn't want to have that hard-coded up in main, because then every time I wanted to run this block of code, I'd have to rewrite it in main. So you might see this appear 2, 3, 4, 5 times, depending on how many times I wanted this block of code to run. So very wasteful. You know, that totally goes against that drive principle. Don't repeat yourself. So anytime that we find that we have code that you know, and I've experienced this too. I've actually just sat down, started writing code, and as I'm writing it, I'm writing a block of code, and then I have something happen, and then I realize, oh, I need to write that same block of code again, and then I'll make something happen, and oh, I got to do that again. And so as you're writing your code, you go, well, this is not panning out the way I expected. I'm writing this block over and over again. That's, I know, illegal. Well, I can't say illegal, but it's frowned upon, be a better way to say that. So when we find ourselves doing that, then what the brain should start doing for us is say, hey, wait a minute, we could wrap that inside of a method, and then every time we want that block of code to run, all we got to do is call the method. So let's look at the syntax of the method, and then we'll come back to our main method here, and we'll talk about how we call the method and pass a value into it. So this is the declaration of the method that you see inside of this red box here. Private, public, just really determines whether other blocks of code within our program can use this method. So private just means that only the code inside of this program can use it. So you're not going to have to worry about that. Whether you put public or private there is not going to impact your code initially. Static isn't a very important word. When you're embedding methods into your program, if you want to be able to use those methods within the actual program where it's written, you need to add this keyword static in there. Because otherwise, and I won't spend a lot of time on this, I'll just kind of state it as a statement. When you have a method, usually it's attached to a class, and really technically we do have a class called program here, right? So we're actually attaching it to the class. So in object-oriented programming environments, typically the way that we get access to the method is we would first have to make a copy of the entire class here, program, assign it to some variable name, and then when I use that new variable name, then it would have access to this method. To override that default nature, what we do is we put that keyword static in here. In fact, look at your main method. Your main method also has static. And notice too how the order doesn't really matter here as far as the public and the private is the accessibility. And then the static is whether or not we have to create an instance of our class program before we can use it or not. Static says, no, you don't. If I don't have static there, then I'd always have to create a copy of program just to be able to use the main method, or in this case here, our calculate discount method. So make a note to yourself as far as your methods having the keyword static in them, because you will be writing a method and that method will not work unless you have that keyword static there in what we call the header of the method. So the header, as you can see, is just all the information here before we hit the curly braces. So static is key. Then after static, you're going to see either a data type, or if we look back to our main method, the keyword void. So the keyword void just means that the method that we're running does not return a value. In the calculate discount example, we are going to process some numbers here and return the results of this calculation. So we're going to return it as an integer. So that's what we put in the header of our method we tell the caller, hey, we're going to pass a value back to you, and it's going to be of type integer. Then you have the actual name of the method. You can call it whatever you want, as long as it's not one of the key words from the language. So in this case, and as I said before, you want to, both for your variables and your methods, you want to make them, you want to name them so that, you know, it's very obvious what the intention is of that variable or of that method. So calculate discount, that's pretty straightforward, right? If we call that method, we can assume that it's going to take our quantity value and calculate the discount. In the parentheses, so all methods will be followed, or will have a name and then followed by a set of parentheses. Sometimes, like main, the parentheses will be empty because we're not actually, that method isn't receiving any values from the caller. In the case of our calculate discount, it is going to receive a value. So you can see here in the main method, when I actually call my method, I'm passing to it the quantity that was received as input up here in the main method. So we need to get that value that the user typed in here and then pass it to the method, because that's the only way that this method is going to know what the value of quantity is, because quantity is not a global variable. Quantity only exists, you know, as far as the compiler is concerned, this variable quantity only exists in this main method. It's local to the main method. So what we need to do to get our custom method here to be able to use the value from quantity is we have to pass quantity to it. So this is called, this is the calling statement here in main. We're calling the method and we're passing what's called an argument to the method. In this case, the argument is the value of what the user typed in as their quantity. From the method's perspective, when we declare the method here in the header, we want to identify that it accepts the value from the caller. And here, again, from the method's perspective, it's called a parameter. So the caller passes arguments to the method which will accept one or more parameters. And so we're defining in the parentheses that the name that we want to use, and we could have called this ABC. It doesn't have to match the name that's being passed to it. So what's really happening in the compiler here, as soon as you call this, your program calls this method, it makes a copy of this value quantity, and it passes that value to that method, and the method says, okay, well, I'm going to take the value you're giving me here, and I'm going to call it this. Now, we happen to use the same name here, but we could have put ABC, XYZ, Australopithecus pithecanthropus. We could have put anything there. It's just, this is how, this name that we put here is how we'll reference it internally with that value that got passed to it. We'll reference it internally within the method, the custom method there. So in order to run the method, we had to have the keyword static. We had to identify that it's returning a value. It'll be of type integer. We had a name for the method, calculate the discount, and then we defined a parameter, in this case, one parameter accepted, and it'll be of type integer. So if I passed a string from up here, that would cause a problem here, right? Because it's expecting an integer. So once we've defined that we've got an integer and it's coming in, we're going to call it quantity, then you can see here in the actual block, the method itself, we're using quantity then to make that determination using if blocks. If the discount is, and I reversed this because I thought it sort of simplified it a little bit. If the quantity is greater than or equal to 100, we give them that 20 discount. Else if it's greater than or equal to 50, we get the 15. Else if it's greater than or equal to 10, they get the 10, and else discount 5. Now you might be thinking to yourself, well, what if they purchase 100 units? Doesn't that make this statement here true also, and this statement here true also? Yes, it does. But you have to remember, when we're using else if, it only checks and it only runs the results of a single if or else if. So out of this entire group here, these first three, as soon as it hits a true, then it runs whatever the statement is to the right there, because this is just shorthand if. We didn't put in the curly braces. If you only have one statement to run for an if or an else if, you don't need to put it in the curly braces. You can list it out to the right after the expression. So all we're saying is if it is greater than or equal to 100, then give them 20 as a discount and skip all the rest of this. So the idea is that I set it up so that, you know, the first value, the higher values, you know, those, if they're true first, then we just skip out of it. We could have done it the other way as well. The order doesn't really matter in that particular example. But again, just kind of really emphasizing how that else if works and how that else works. It's all based on a particular expression and whether it evaluates the true. And as soon as an expression evaluates the true, we skip the rest of it. And then after we skip the rest, you can see what we're returning then is whatever discount then is at that point in time, because that's what we're doing here in each time that we are doing our ifs. If we meet that, if that expression is true, that's when we're actually assigning the value to our discount variable, right? So the discount's going to have some value, 20, 15, 10, or 5. That'll be assigned to it based on the ifs. And so once this block of code runs, then it's going to return the results of our discount back to the caller here. And you can see now that I've put in our console.writeLine statement is where I actually called that function. In fact, we could even done this with the string interpolator if we wanted to. I used the composite method here where I put the placeholder up here and then comma, and then the running of the function out to the right of it. So that should output your discount is colon space and then whatever discount is after we've run this custom method. So I'm guessing there's going to be some questions here. Go ahead and fire them away. What's making sense? What's not making sense here? This can't be 100% fully understandable. Come on. I really did that outstanding a job explaining it, huh? All right. Well, since you're all being bashful, let's move on now and actually go ahead and set it up using our code down here, the decision statement, using this decision statements to calculate customer discount. And I've got it in 3 different formats for you, but of course, for the assignment that you're eventually going to turn in here, that's going to be pretty much based on this. I think the only difference is you get a different decision table, which has different discount values in it. We'll take a look at that here in just a second. So let's go ahead and copy this.
Be a problem for the assignment.
I'm sorry, say that again.
I didn't follow that structure for the assignment when I was writing the code for it. Would that be fine as long as it produces the right outputs?
Yeah, that's really all I'm looking for is the correct output, unless it's got some really quirky errors in it. Why don't we do this? Let me copy this and go here. Let me take a look because I just forget off the top of my head exactly which. So this is going to be assignment 3 that you're working on, right? Yeah, so there's the decision table. You can see that you're going to use in the actual assignment. So in this case, it's less than 5, less than 25, less than 50, and the discount amounts are different too. So the structure is still going to be the same. It's just all you're changing then is the expressions, you know, what you're evaluating for. So I had quantity equal to or greater than 100. You could have quantity equal to or greater than 50, and then equal to or greater than 25, equal to or greater than 5, and then the appropriate discount amounts should be assigned. But as far as the structure of your code goes, let me just go ahead now and open up Visual Studio. And actually, let's create, we can close this solution up. Create a new one. Yeah, this is really getting irritating, the fact that it has to load my recents over on the left before I can do anything. All right, so let's again choose console.app.NET Core C#, and then we'll make this assignment 3. And then we'll just replace this with the sample code that I copied the URL, so I got to go back and get the sample code. So we'll recopy that, come back here, and there we go. Okay, so again, this is based on the original table that we had, right? Let me pull that over real quick here. So yeah, this one is the 2015 10 5 based on the values of 100, 50, and 10. Yeah. So that's matching that one. You, for your assignment, did I close? I must have closed that window. Oh no, there it is, right there. Okay, so your assignment, you can see again, the quantities are going to be different, and let's do this, get it small enough here, just so we can see it side by side with the actual code we got here. There we go. So here then, you're going to write the basic structure of the code should be similar to this. Again, have a prompt, ask them to enter their quantity, and then take the input, convert it, either using convert or int32. I don't really care which one you use, just as long as that conversion occurs, because that's necessary. Assign it to an integer quantity, and then when you go to write your output, you can see now I did use the string interpolation in this particular example. When you call the function inside of the string interpolation, just remember that you want to put it inside of curly braces. This % is actually the character that we're going to display after the number, so 10%, 15%. So that's just a string value. But everything inside of the curly braces, see, that's the call to my custom method, and then passing into it the quantity that we converted up here. So getting back to our table, down in here now, this first value would be greater than or equal to 50. The second one is going to be greater than or equal to 25. And the third one would be greater than or equal to 5. And then your percentages are going to be 15%, 10%, 5%, and then the catch-all is going to be 1%. Does that make sense?
Wait, what was the percentages again?
Well, look at the graphic on the right here. So the quantity values in the assignment are less than 5, less than 25, less than 50. So now look at your code. That's not the same here. So you need to change this one here to the lowest value, which is the 5. Can't do it with the, let's do it this way. Shrink up our Visual Studio a little bit. So we take the lowest value is 5, so we want to put that one in here. Then the next greater value, 25, and then the highest value in that table is 50. The percentages then, following from the right and working our way back to the left, so the highest percentage is for the 50, and so that's going to be 15%. The second one is 10%, and 5% for the third one, and then the catch-all in that example, in that decision table, is 1%. So that's the way the values will read right there.
Okay, thanks.
So you see, if we save that, we go ahead and run it. Going to put in a quantity here. Let's check it out at 50 or greater. So we'll do 50. Gives us the 15% discount. Run it again. Then we'll do the 25. So that should give us the 10%. Run it again. And this time we're going to put in 5. That should give us the 5%. And then anything less than 5, let's put 3 in there. That should give us 1%. So that's essentially how I evaluate that. When I go to run your program, put in the 3 values or the 4 values essentially, and make sure we get the right percentages out. As far as the structure of your code, you know, I would like it to be nice and professional looking, but I haven't been marking it down for, you know, wrong indents or things of that nature. Every once in a while, again, I don't think it's in the face-to-face class. I think people are on the online class are searching online for some of this stuff. And so they'll have some really wild using directives up here when at this point, the only thing you're ever going to need, wait until you get to the IO in the next lesson, or actually as lesson 11. But anyway, you'll always just have the system directive in there because that covers everything. Your conversion, your console, your write line, your read line, all that kind of stuff. Everything's all in that system library. A couple other examples just of problems that I've seen is sometimes that gets left off completely and I'm just getting a namespace. So that's not a runnable program. If I go to run this now, Control F5, you can see I get a build error, right? Because it can't find console. It can't find int32. Why can't it? Well, because we didn't put using system up here. And just while I'm thinking about it, let me show you something here. The reason you put system up here is just so you don't have to type it over and over again here in your code, because I can do system.console, right? So now I'm telling the compiler, hey, you have to go to that system library. That's where you're going to find console. But the problem is I have to do that for every one of these objects in here now. So system.int32 and then system.console again. And then here also my console read line, that needs to be system.console.readline. So I can get away without having a using directive, but the problem is now I'm violating the dry rule. I'm repeating myself over and over again when I don't have to. All I have to do is add that using directive to identify that the compiler should just have that loaded in memory, ready to go as soon as we start processing our code. So now I can go in here and I can remove then all those systems. So I hadn't shown that to you before. I thought you might find that interesting. So that's the whole point of that using directive, is just simply identifying to the compiler where to look for these objects that we're borrowing from Microsoft. So as far as the lesson goes, as far as the assignment goes, that pretty much covers everything. And so assignment 3 is due tonight, is it? Yeah, that's a weird responsive design they got going there. So assignment
due on the
3,
30th.
Thursday, is that Thursday, I think? Right, today's the 28th? Yeah, so actually that's going to be due then on Thursday. So when we get together, and that's mainly because, you know, we are using custom methods now. And so when we go through lesson 10, that covers custom methods as well. So that'll be kind of a lot of reiteration of what we covered today, because I gave you the basics of how methods work. But we'll go over that again on lesson 10, and then also we'll go over assignment 3 as well on Thursday. But if you'd like to get a jump on it, you're welcome to do so. Any questions, comments, anything that I should know about, or anything you would like to deal with before we call it a day?
Nope.
For assignment 3, were we just supposed to like copy that example that you had up and then just input the percentages?
That's basically what I was showing you here, yeah. So just, you can use the example code that I gave you, but just remember, you do need to change the values in it. Right,
Yeah,
those are
okay,
different than what was in the example, because the example is based on the
right.
original decision table. I gave you a different decision table for the assignment.
Right, yeah, and that's what I was asking. So basically we just input the percentages in.
Yep.
Okay.
That's all you got to do. It's that easy. Main thing is just, you know, getting you to write good code, using different elements as you learn them.
Okay, thank you.
You're welcome. Anybody else? Anything at all that you want to discuss related to the class? I do need to qualify that.
No, sir.
No, I'm good.
Okay, then have a good afternoon, and I'll see you back here on Thursday, and we'll cover lesson 10, and again, we'll go over assignment 3 as well. So have a good
Thank you.
afternoon.
Thank
Have a
you.
great afternoon. Thanks all, and bye.
Bye-bye.